This is part B of problem 2 on practice exam 1 of module 1 in the book Problem Solving Guide for Electromagnetism and Optics. There are 2-point charges located on the x-axis, -6 at +2, 0, and a +3 nanocoulomb charge at -3 centimeters, 0. Where can we put an electron so it will experience 0 electrical force? It will not accelerate, it will just sit there. Let's think, if we put it between the two charges, the electron will be repelled by the -6 and attracted by the +3, so both charges are pushing it or pulling it to the left. There's no way the force can cancel in here. If we go out here, the forces are in opposite directions. The -6 will be pushing it away. The +3 will be pulling it back. But the problem is the -6 is always going to have a bigger force because the magnitude of the charge is bigger and it's closer. The only region where the forces can cancel is back here somewhere. The +3 will be pulling it in to the right, and the -6 will be pushing it to the left. The 3 nanocoulomb charge has a smaller magnitude, but it's closer. So there's some place in here that the field will be 0, and now we can put on our math and physics hat and try to find it. It's got to be to the left of the +3 nanocoulomb charge. So let's define some distance x away from the +3. The field is 0 right there. Some distance away from the +3 nanocoulomb charge to the left. So the magnitude of the force on the electron from the +3 nanocoulomb charge, which is a distance x away because we defined it that way, kq, q1, q2, divided by x squared, the distance between them. Now this 6 is x plus 5 centimeters away. It's 5 centimeters further. So we can write that equation, putting in the right charge, 6 nanocoulomb charge, there's the distance. And these forces are equal in magnitude. They're opposite in direction. That's the only places they can balance. So we set them equal. Now we can let's make it easy on ourselves, right? We'll cancel a lot of things. The k's cancel, the charge on electron cancels, the coulombs cancel, and we can get rid of the 10 to the -9th as well. Cross multiply, we get this simple equation. And to make it easy on yourself, don't FOIL this out, just take the square root. Take the square root of both sides. And now we can multiply the square root of 3 through, and we have one equation, one unknown. Collect the x's and solve for x. 12.1 centimeters. Now, the question asks, give the coordinates of the point. Don't screw up now. It's 12.1 centimeters away from this point. So here's the origin of the coordinate system. The point where the electric field is 0, minus 15.1 centimeters, comma 0. 15.1 centimeters along the negative x-axis. That's problem 2B, practice exam 1, module 1 in the book Problem Solving Guide for Electromagnetism and Optics.